Hey guys, here is your solutions video for the practice x versus t graphs. I'm going to try to make this one short and sweet, really break it down, treat it more of a solution than as a more teaching style for it. So for the first one, we're given a position versus time graph. So general rule of thumb for always how to start these is to draw your axes. So here we've got velocity and time. So then the next one, we'll have a position time graph. Following one will be velocity time again. And always make sure that you're labeling your axes. Then we will have position versus time. So since we have our axes labeled, now we can go ahead and start drawing our slopes. So the first one, we can break it up into three different pieces. So we will have a positive velocity, and then we jump down and we have a zero velocity, and then we have a negative velocity. For the one right below that, we have a negative velocity. So we'll start, and if we have a negative velocity, that means that the slope on the position time graph is negative. So we will have a negative slope. And then it jumps and says that we have a positive velocity, which means a positive slope. And now this positive, this numerical value here is less than the numerical value for the negative. So this slope will not be as steep. And then it says that we have zero velocity. So then the object is not moving. Third one, again, breaking this up, we have a negative velocity. It's not very negative, the slope isn't too steep, so we have a negative velocity. And then we have a zero velocity for a little bit, and then we have a pretty steep negative velocity there to finish off. So that's so then that velocity is greater than the velocity for the first part. And then the fourth one, it starts where we have a zero velocity, so the object is not moving. So we'll go ahead and just draw that it was at the origin, so it's not moving. And then we have a big spike in velocity. There's a pretty high velocity there, that number is. And then we have a negative velocity where the number is less than the positive one. So this value here, when you take the absolute value, is less than that value there. And that's going to impact the slopiness of the lines. So then written descriptions. The first one, the object has a positive velocity, then sits still, then has a negative velocity. The second one, the object has a negative velocity, then a positive velocity, then sits still. Third one, object has a negative velocity, sits still, and then has a greater negative velocity. And the fourth one, the object is sitting still, it's at rest, then has a positive velocity, then has a slightly negative velocity. So our motion maps, you can go ahead and draw those in now. So motion map, remember, we'll always draw that number line, which represents position. And so this one starts in front of the origin, has a positive constant velocity, and then it rests, and then it has a greater negative constant velocity than it did positive velocity. Next one, again, draw our number line, our initial position on there. So this one starts with a positive initial position, a negative constant velocity, and then it turns around and has a positive velocity, and then it sits still. Third one, I'll draw the axis for the fourth one. So here the third one, again I'll draw my initial positions on each of these. And here we have a positive initial position, and then it has a slight negative velocity, and then it sits still, and then has a pretty quick negative velocity back to the origin, and all those are constant. Then the fourth one here, we're resting at the origin, and then we have a pretty good positive constant velocity. It's moving pretty quickly, and then it's going to turn around and move back towards the origin at a constant negative velocity. So now we move on to the next part of the sheet here. Go ahead and draw all the axes in. So we have all the position time ones. We'll add all the velocity time ones. So now, again, we will have to start looking at the written description. So here we have an object moving with a constant positive velocity for 4 seconds. So positive velocity, 4 seconds. Starting him at the origin. Constant velocity on the position time graph is the slope. So we have a positive slope for 4 seconds. It's going to stop for 2 seconds, which means that its position isn't changing with time. So we have a flat line there, and then it returns to the initial position in 2 seconds. So that is going to return back to 0. So we put this on our velocity time graph. We have a positive velocity, we have a 0 velocity, and then because it travels the same distance over half the time, the magnitude is twice that of the initial, that constant positive velocity. Draw our motion map. We'll set 0. We have a positive velocity, and then we rest, and then head back at a faster velocity towards the origin. Next one, we have our motion map, and we'll consider that it is starting at a position of 0. So if it is starting at a position of 0, and actually for the simplicity of the axes that I have drawn, we'll call where it rests at 0, and then we call where it starts, we'll just call that 5. We'll just give it a number. So that means that it's starting at 5, and it's moving at a negative velocity towards the origin. It's going to stay on the origin for 2 counts, and then slowly move back towards where it began. So we start with a negative velocity, then a 0 velocity, and then a positive velocity whose magnitude is less than that of the velocity that it began with. So next one, we have 2 different objects here. Object A starts 10 meters to the right of position 0 and moves to the left at 2 meters per second. So we'll go ahead and call that the green line. The green line will be object A, and then the blue line will be object B, and object B starts at 0 and moves to the right at 3 meters per second. Same as that the 3 meter per second will be a steeper line than the 2 meter per second. And the reason that one is positive is because it's moving to the right. And whenever we draw our number line, objects moving to the right have positive velocity, objects moving to the left have negative velocity. So I'll draw my motion maps here, and then I'll give that axis a different color for simplicity. And now I've got object B I'll start with, starting at position 0. So we'll start at position 0 here, and it will be moving at 3 meters per second. Now object 2 or object A, that will be the green one, so that's position of 0. We have position of 10, so that starts at 10, and then that is moving at 2 meters per second towards the origin. So those arrows are not nearly as long. And now the last one, again, object A will be the green one. So object A is starting at the origin, and it has some constant velocity, and we know it's positive constant velocity because it's moving to the right. Object B will again be blue. This one starts away from the origin, and it starts more positive because of where it starts on that number line. It's more to the right, so it's going to be more positive. Those arrow lengths are the same as the other one, so its slope will be the same as well. The velocity time graph, that is going to be represented by them traveling at the same velocity, so their lines will actually be overlapped. So that is your solution video for your practice X versus T graphs.